a non-metal electrode. For example, here we can have hydrogen electrode, chlorine electrode, oxygen electrode we can have. Then how to construct a non-metal electrode? Of course, we take a vessel in which solution of a non-metal ion, like H plus ion, aqueous H plus ion for hydrogen electrode, a solution of aqueous chloride ion for chlorine electrode, a solution of hydroxide ion for oxygen electrode. Any of the solution will be taken, like for example, if you take HCl, that solution can be used as an electrolyte for a hydrogen electrode as well as chlorine electrode. So, this is a solution of H plus ion, means an acid, any acid, sulfuric acid, hydrochloric acid, nitric acid, any acid can be used. And if you are taking a chlorine gas electrode, then this should be solution of chloride ion, means either NaCl, KCl, HCl, any of that can be taken. But if you are making an oxygen electrode, then this should be sodium hydroxide, potassium hydroxide, calcium hydroxide, barium hydroxide, any of such solution should be taken. Now, into this a glass tube in which a platinum rod, platinum wire, this is glass tube. A glass tube is placed into which a platinum wire is inserted, and this is filled with the corresponding gas, hydrogen gas at certain pressure P. So, the combination is hydrogen electrode is given, that combination is aqueous H plus, here this will have a certain concentration C in combination with H plus ion solution of H plus ion, that is any acid, in contact with hydrogen gas. But as you know, hydrogen gas or chlorine gas or oxygen gas, for that matter any gas, cannot act as a conductor. So, we require a conducting medium, and that conducting medium is platinum wire, and this hydrogen gas at what pressure that we have taken, P should be mentioned, and platinum, the platinum wire is being used. So, the representation must be like this, H plus ion getting reduced to H2, or if it is chlorine electrode, then the representation will be the other way, that so hydrogen electrode is H plus aqueous concentration C mole per liter to hydrogen gas at a pressure P is filled and it is platinum wire is inserted. That is the representation for hydrogen electrode. Chlorine electrode, the representation is chlorine gas at a pressure P with platinum wire inserted in it and chloride. Here the ion comes next, because here hydrogen ion is reduced to hydrogen gas, here chlorine gas is reduced to chloride. So, here I am writing according to IUPAC, the standard is that we should represent any electrode in reduction form. So, H plus ion reduction to H2, chlorine reduction to chloride. Oxygen, we represent it as that oxygen gas at a pressure P into OH minus aqueous at some concentration C. this is how we represent the gas electrodes. Hydrogen ion reduce it to hydrogen gas, chlorine gas reduce it to chloride, oxygen gas reduce it to hydroxide. Here at what pressure the gases are being taken and at what concentration the ions are taken, that concentration and pressure, they will play a very important role in the net EMF of the galvanic cell. That in the mathematical part under the Nernst equation, how the pressure and concentration will change the EMF, there we discuss. As you know very well that in the thermodynamics, we say that the free energy change of a reaction depends on the concentration or the active mass of the reactants and products. So, here the pressure and concentration are the terms which are nothing but we are taking in place of the active mass. So, it is the active mass of the reactant and product that will decide the free energy change of the reaction, and EMF of in a galvanic cell is a relation of free energy, delta G is equal to minus NFE. So, at what pressure the gas is filled, at what concentration of the ion that we take, they both are important. So, while representing the cell notations, the pressure and concentration, they both have to be mentioned very clearly in the brackets. So, this is a half cell representation for gas electrode, and the reactions are here H plus reduced to H2, chlorine is reduced to chloride, oxygen is reduced to hydroxide. So, this is a half cell notation, and these are the representations. Now, like zinc and copper combination that we have seen in the previous case, instead of copper, any of these can be used as cathode, or copper can be coupled with any of these three, where copper will act as anode and any of these three will act as cathode. Copper will act as anode and these three will any of these three will act as cathode. It all depends on what you call the reactivity, the electropositive, and if you take hydrogen standard reduction potential value or the is less than the copper. So, there hydrogen will be still considered as anode, copper will be cathode, but with these two, copper will be anode and these two, any of this what we are using will be cathode. That one by one, what are the combinations, that one by one we see.